In this video here, we're going to be talking about dividing polynomials. Now, I did another video where I talked about, just kind of going through the long division algorithm with numbers and just kind of reminding you how to do the long division and the steps you have to take. And we also did an example there of dividing polynomials. In this one, I'm just going to go ahead and do a couple examples where we just go ahead and divide polynomials without a whole lot of explanation of the division process, right? So here's our first example we're going to do. We have 8x to the fourth plus 6x squared minus 3x plus 1 over 2x squared minus x plus 2. All right, so one of the tricky things that sometimes happens when you're dividing polynomials that you really have to watch out for is sometimes one of your polynomials, and it could be either one, the numerator or the denominator, your dividend or your divisor, sometimes one of them is missing one of the powers of x, right? What I mean here is we have an 8x to the fourth power, so we have an x to the fourth, but then our next term is an x to the second, right? We're missing an x to the third power. Now, when we go ahead and write this out in like the division format for long division, we have to make sure we include all the powers of x less than the highest power that we have, right? And as we're going through the problem, I'll explain why it's really important that we do that. We have to recognize that from the start so that you set things up correctly. Right, so I take my dividend here, or no, my divisor here, the thing I'm dividing by, so that's going to be the 2x squared minus x plus 2, right? I write that outside of the division house. And then on the inside, I put this polynomial that's in the numerator, 8x to the fourth. Now, I don't have that x to the third term, but I need to include an x to the third here, so I write plus 0x to the third, right? And the reason I do that is basically for place value, right? I have an x to the fourth place, I have an x to the third, x squared, x to the first, and then a constant place, right? If I skip one of those places, when I start doing my multiplying and all that stuff, sometimes things get out of whack and they don't add up appropriately, and it just causes confusion and mistakes, right? So we want to make sure we leave a place value. Just like when you're writing numbers, like you have a place for the hundreds and the tens and the ones. If your number is 508 and you have 0 tens, you still put a 0 there for that tens place. If you leave that out, then it looks like the number's just 58, and that's going to screw things up, right? Well, same idea here with that 0x to the third. I need every power of x to be represented here so things don't get misaligned when I'm doing this problem. All right, so 8x to the fourth plus 0x to the third, and then the rest of this is fine, plus 6x squared minus 3x plus 1. All right, just barely fits on the board there. All right, and then we go through our division algorithm, right, which says I have to take the first term on the outside here and divide that into the first term that's on the inside, right? When I'm figuring out what numbers to put up above, remember, I only look at the first terms on the outside and the inside, right? So two ways to think about it. You can think about it as, well, if I had 8x to the fourth and I divided that by 2x squared, what would that leave me? Well, 2 goes into 8 4 times. X squared is going to cancel out 2 of those x's, so I get 4x squared. All right, so I have a 4x squared up there. Now another way, and the way I usually think about this is, well, I have a 2x squared. What would I have to multiply that by to get 8x to the fourth power? Well, I would have to multiply the 2 times a 4 to get 8, and I would have to multiply x squared times another x squared in order to make it x to the fourth power. All right, so whichever way you're more comfortable with thinking about it, do it that way. As long as you end up with the correct result here, it's fine. All right, once I get that number up there, the next thing I do is I multiply that 4x to this, or 4x squared times everything that's out front. Right? When I'm figuring out what number to put up here, I only look at the first term, but then when it comes time to multiply it, I multiply it by everything that's out there, and I write all that stuff underneath. Right, so 4x squared times 2x squared is going to be 8x to the fourth power. And if we did things correctly, what I just wrote down here should be exactly the same as what's directly above it. And it is. That's a sign that we did this correctly. Right, so those two always should be exactly the same. If they're not, stop right there, and you put the wrong number up top, or you multiplied it wrong, so you need to fix whatever it is you messed up on. All right, so 4x squared times negative x is going to be negative 5x to the third. And again, that's why it was important for us to put the 0x to the third here, so that when I multiply this and I get that x to the third term, it's lined up with another x to the third term. Right? If I didn't have this here and I just wrote the 6x squared next to the 8x to the fourth, well, then my 5x to the third is underneath the 6x squared, and those are not like terms, so that when I try to add or when I try to subtract those, I can't combine them together, and it just kind of screws everything up. Right? So that's why it's important, if you're missing one of the terms, one of the powers of x, you need to put at 0 x to the third there, so that x to the fourth, x to the third, x squared, it all lines up. All right, 4x squared times 2 is going to give us a plus 8x squared. Right? And if when you're setting up the problem, if you don't recognize that and you forget to put that 0x to the third there, and then when you're doing this part and you get that minus 5x to the third, and you notice that that's underneath the 6x squared, you don't have to like scrap everything you've done. All you have to do is erase the stuff that you had up here and just kind of slide it over a little bit and put that 0x to the third in place, and then you can continue with the problem. Right? So it's not like the end of the world if you missed it. As long as you catch it when it comes up, that, oh, I need an x to the third here to combine with this negative 5x to the third, then you fill it in and you'll be fine from there. All right, so I multiply this times all that stuff there, I get that down below, and then I have to subtract. All right, so I subtract all this, which remember, when we're subtracting here, we have to distribute that negative to everything that's inside here. So this is going to become a negative 8x to the fourth, it's going to become a positive 5x to the third, and a negative 8x squared. All right, so that minus out front changes the sign of everything I have down in there. Right, so 8x to the fourth minus 8x to the fourth, that cancels out. Those first terms should cancel out every single time. If you did all this correctly, always goes away. Right, I have 0x to the third plus 5x to the third, so that's going to be a 5x to the third. And then I have a 6x squared minus an 8x squared, that's going to be a minus 2x squared. All right, so that's my results of subtraction. And now I bring down the rest of what I have. Minus 3x plus 1. Right, that's just taking these two and copying them down. All right, so that's my first run through this process, and now I do it again. All right, so now I go back to my first term on the outside. Hold on a second. I screwed something up here. I wonder if you guys noticed that I did something wrong here. When you do 4x squared times minus x, that's negative 4x to the third, not negative 5x to the third. I don't know why I thought that 4 times 1 was equal to 5. That was pretty dumb. And so if you noticed that and you were like wondering when I was going to figure out that I did something wrong there, I finally figured out that I did something wrong. All right, so 4x squared times negative x should be negative 4x to the third. I honestly don't know why I put a 5 there. That's slightly embarrassing. But anyway, at least I caught it before I got too far. All right, so that should make that a positive 4x to the third, not a negative 4x, or not a 5x to the third. All right, sorry about that. And if you didn't notice that and you wrote it down, you should have been paying better attention and realized that I did something wrong there. All right, so there we go. We got that now. Pretty sure that's all correct. I should maybe look over everything else I did. Everything else looks like I didn't make any mistakes. Okay, so now I do the same thing, right? I take the 2x squared that's out front, just the first term out front, and I put that into just the first term that's on the inside. All right, so 2x squared into 4x to the third. Well, I have to multiply 2 times 2 to get 4. So it's going to be plus 2. And I have to multiply x squared times x to make it x to the third power. All right, so I have a 2x. When I do 2x times now all this stuff, 2x times 2x squared is going to be 4x to the third, which again should be exactly the same as the term right above it. 2x times minus x, let's make sure I do this right this time, that's going to be minus 2x squared. 2x times 2 is going to be plus 4x. All right. Just looking at it again to make sure I don't make any more mistakes. Looks like I did all that right. And then once again, we subtract all this stuff from what's up above. All right, so when I subtract, I have to distribute that negative, so that makes it a minus 4x to the third. It's going to be a plus 2x squared, and that's going to be a minus 4x. All right, so the 4x to the third and the negative 4x to the third, once again, those first terms always should get canceled out at this point. The minus 2x squared and the plus 2x squared, those actually get canceled out this time. That doesn't always happen, but every once in a while, you kind of get two things to cancel out. If it happens, that's great, because it's actually going to save us some time, or save us from doing another extra step of the problem. So the x squareds cancel out here. I have a negative 3x minus 4x, so that's going to be a minus 7x. And then I bring down that plus 1, and I get plus 1. All right, so I got negative 7x plus 1. And now I'm done, right? Because, a couple reasons, right? The 2x squared, I can't put that into negative 7x, right? Because the x squared is a higher degree than the x to the first power that's down here, right? So your clue of when to stop is when whatever's remaining down here after you do the subtraction, if that has a lower degree than your divisor out here, you're done. And then whatever's down here is just your remainder, right? So it's going to be 4x squared plus 2x remainder negative 7x plus 1. All right, so if I were to write out the answer to this, or how this division problem changes when I actually divide it, or what that fraction changes into, that's going to give me 4x squared plus 2x, and then plus my remainder, negative 7x plus 1 over this divisor here, the 2x squared minus x plus 2. You guys could probably hardly even see what I wrote there at the end. But that's what it is. It's the quotient, right? That's what we have up there. So the 4x squared plus 2x, and then plus a fraction, where the fraction is the remainder, the 7x plus 1 over this divisor over here. All right, so maybe I can write that a little more clearly for you to see. So it would be 4x squared plus 2x, right? That's my quotient that I got, plus the remainder, negative 7x plus 1 over my original denominator, my original divisor, 2x squared minus x plus 2. Right? That's what this fraction here is equal to when I actually divide those polynomials. All right, so that's one example of dividing polynomials. That one took kind of a long time. Remember the key things. If you're missing that term, that x to the third, you have to put that 0x to the third in there so that everything lines up. And then just being real careful when you're picking your signs, when you're putting the numbers up here, when you're multiplying it out. When you have that minus, you have to distribute the negative all the way through. So those are little things to watch out for. All right, I'm going to pause this recording and put up one example that I'll go through pretty quick, just so you can see another example of doing the long division. All right, next example we're going to do here, we have x to the fourth plus 4x squared minus 45 divided by x squared plus 9. Notice this one's written a little bit different. It's written as an actual, with like the actual division symbol there rather than written as a fraction. But we can set it up the same way. So we're dividing by the x squared plus 9. But notice, right, the x squared plus 9 is missing the x term. So I write this as x squared plus 0x plus 9 just to hold that place. And then the x to the fourth plus 4x squared minus 45, that's missing the x to the third term and also the x term. So I have to put a 0x to the third plus a 0x, right? Again, just to hold the place so that when I do all this, I don't have things not aligned. I don't want like an x to the third lined up with an x squared, okay? All right, so then I go to it. I take my first term out here, x squared, my first term in there, x to the fourth. What do I have to multiply x squared by to get x to the fourth? Well, I need to multiply it by x squared. All right, x squared times x squared is going to give me x to the fourth power. X squared times 0x is going to be actually 0x to the third. X squared times 9 is going to be plus 9x squared. All right, and then I subtract. Yeah, well, let me distribute the negative, so that's going to be a negative, that's going to be a negative, that's going to be all negatives. The x to the fourths are going to cancel out like they always should. That first term should always cancel out. The x to the thirds, they're both zeros, so in this case, putting that there actually didn't really help me at all, but it didn't hurt either. It's always better to be safe than sorry. Sometimes it turns out you just get a 0x to the third, so it's like not even necessary for it to be there. But if this had turned out to be something else, then we would have needed to have it there. All right, and then I have a 4x squared minus 9x squared. That's going to be a negative 5x squared. All right, so 4x, 4 minus 9 is negative 5x squared. Okay, and then I bring down the rest of my stuff here. So I get plus 0x and then minus 45 from that. All right, and then I do it again. I take my first term here, the x squared. What do I multiply that by to get negative 5x squared? Well, I need to multiply it by negative 5. All right, and then I multiply it all out. So negative 5 times x squared is negative 5x squared. Again, should be exactly the same as what's up above. It's a good sign. Negative 5 times 0x is going to be minus 0x or plus 0x. It doesn't really matter. Negative 5 times 9 is going to be negative 45. All right, and then once again I subtract. I distribute that negative all the way through, so it's going to be a plus, and a plus. And then the x squares cancel out there, negative 5x squared plus 5x squared. The 0x and the 0x, that adds up to 0. And the negative 45 and the positive 45 actually also cancel out this time, and we end up with no remainder at all. Right? Sometimes that happens. Sometimes you do division problems and you have no remainder. Right? If you do 20 divided by 4, that just equals 5, and there's no remainder. Well, that also happens sometimes with polynomials. All right, so in this case, this x to the fourth plus 4x squared minus 45 divided by x squared plus 9 equals x squared minus 5. With no remainder, it divides evenly. All right, what that tells me is that these two things here are factors of this original polynomial. Right? If I multiply those two together, it gives me the exact same thing. There was no remainder or anything else like that. All right, so that's some long division of polynomials. I hope it was helpful. That's it.